Hello, everyone. Thank you for joining us today for our ALS Webinar Wednesday series. My name is Alejandra Herrera, and I'm the Marketing Coordinator for ALS North America, and I will be facilitating the webinar today. If you're having technical issues with our webinar platform or you have any questions, please use the chat function at the bottom of the screen. You can also select the hand icon to notify me of your status so I can assist you. All questions regarding the webinar material will be answered at the end of the presentation. Our presenter today is Angela Carlson. Angela has over 15 years of experience in the testing, inspection, and certification industry, developing and managing laboratories focused on testing food, feed, and grain products for quality and safety. Angela has been involved in contaminant testing to ISO 17025 standards, including allergens, GMOs, mycotoxins, and pesticides and chemical residues. She currently manages the ALS Food Laboratory in Houston after joining the ALS team in April 2020 and holds a Bachelor of Science in Chemistry and Biology from South Dakota State University. Today, Angela will be discussing allergen testing for food. Angela, I will now turn it over to you.
Okay, thank you. Can everyone hear me okay? Okay, so today we're going to talk about food allergens, as just mentioned. So first of all, I'm gonna give you an overview of what we're gonna talk about. So we're gonna talk about food allergens, what they are and why they're important. Then we'll go through some of the regulations that are in place here in the US for controlling food allergens. And then what does food allergen management look like in food production, and some different strategies of how you can improve your food allergen management, how testing plays into that, how sampling can affect that, and also talk about exactly how that testing works to help you understand it better. So first of all, what are food allergens? So we have a few definitions there and some pictures to go along with them. So first of all, what is an allergenic food or food ingredient? So as an example there, a peanut. So it's a product that causes an allergic response or an intolerance. And if we go a little bit further, the actual allergen, or we may say antigen, is a specific protein in a food. So the example there is the ARAH1 allergen in a peanut. So that's the specific protein, and the globular structure that you would find if you look it up online, you can find that. And that's what triggers an abnormal immune response. And then we can zoom in yet again, even a little bit more. So within that globular structure of that protein, there's going to be an epitope. And if you were to zoom in, it'd be a very small region of one of those strands. And it is where an antibody would actually bind to that antigen. So first of all, the different food allergens here in the US, we call it the Big 8. So there are 8 categories of allergens that we will be going through a little bit more. And so those are on the screen there for you. So people can have an allergic reaction to almost any food, and there are over 160 known allergens that have been shown, but we only list the major 8 in our regulations, and that covers approximately 90% of the allergic reactions that we see clinically. And so when someone has an allergic reaction, those symptoms can vary from mild to severe. And so in a mild reaction, we'll see swelling of the face, lips, and eyes, hives or welts. And in severe reactions, it can lead to anaphylaxis. And so that's a reaction that can become life-threatening. And so those that are particularly affected by those, so difficulty breathing, swelling of the tongue, tightness of the throat, may even have to carry something like an EpiPen with them if they know that they have those type of reactions. So we also may hear about food intolerances. So currently, if you were to do, there have been surveys, if you were to ask adults in the US, do you have a food allergy? You would get as high as 25% of individuals would respond yes to that question. In reality, clinically, we know that really only 2 to 3% of adults have actual food allergies, and those other percentages is likely due to something like a food intolerance. So, which is not the same of an allergy. The symptoms are less severe and usually are related to digestive issues. And that can be from a number of factors that may be due to disease, such as IBS, celiac disease. It could be due to other health genetic factors, such as lack of enzymes or just sensitivity, or even stress in the individual's life that they end up reacting to different foods. So another pictogram here to kind of show the differences between an allergy versus intolerance. So the reaction, the adverse reaction may be difficult to tell the difference. So for some mild symptoms, it could look the same, whether it's an allergen or an intolerance. But an allergy is immune mediated. So using the IgE molecules in your system would react to that. And so a food allergy typically will happen in minutes to hours, so very quickly, versus a food intolerance can happen very slowly. The quantity of food to cause that reaction is also different. So in a food allergy, extremely small amounts, milligrams or less even of food digested can result in an allergic reaction, versus a food intolerance. It often takes a number of grams of food in order for that to happen. And then the severity of the reaction, again, the food allergen or food allergy responses typically can be very acute and can be about these food allergens. So in 2007, approximately 3 million children under the age of 18 were reported to have food allergies. So we're seeing increases in particular in childhood allergies, and those allergic reactions, when you have that anaphylaxis, can result in death in the worst case scenario. So 2 examples here. So in 2016, Natasha on the left, from a sandwich made by the same company, another young had what was supposed to be dairy-free yogurt. So extreme undeclared food, and that was statistics from the FDA's, that was for the past 3 years and has been, I think, on the list of top causes even longer than that. That's imported, that ended up with import alerts related opportunity to label your product as free from the various different categories of those allergens. And we're seeing an increase from in those categories up to 10%, specifically in the gluten-free category. The increase is expected to be 7 billion. And not only are people with allergies looking at buying these products, but often consumers just want to see it as a lifestyle choice, or they're looking for what is called a clean label. And so there's a big increase for desire of those products, even for those individuals that don't have food allergies. So for the allergens, again, I wanted to bring up the specific list of allergens that are considered the major food categories for the FDA. And so again, the 8 are listed there. So milk, eggs, fish, shellfish, tree nuts, peanuts, wheat, and soybeans. This is under the Food Allergen Labeling and Consumer Act of 2004 set up those categories. So it set up what was the major food allergen categories, and then gave guidance on how food must be labeled if it contains those products. So if it is not a raw ag commodity, if it contains one of those food allergens, it must be labeled with the word contains, followed by the name of that food, along with the common and usual name so that the consumer can recognize that it's present in the product. There is also a final rule for gluten-free labeling. So it is a voluntary, if your product meets the requirements of having less than 20 ppm gluten, there is guidance on how to declare that on your label in order to claim that. There's also, so sesame, one of the allergens that you didn't see in the US FDA major food allergen list, does have other regulations around it. So it does have to be declared in your ingredient statement. And so in November 2020, there was also some draft guidance just released for voluntary declaration of the sesame and the ingredients if the common name isn't already present. So it's still a voluntary, but it is a step forward for sesame. There are some other items for, again, ingredient labeling. They aren't under specifically the allergen regulation, but they do require some declaration of products that have other allergens that you will see on other lists. So towards the bottom there, I've listed specifically sulfiting agents. So in other countries, sulfates are grouped together with allergens. And so in the US, although they're not grouped with the allergens, there is regulation that requires it to be labeled if the concentration is greater than 10 parts per million. So I wanted to show the list of allergens that are for the EU specifically, and you'll see other lists for other countries. So every country has potentially slightly different lists of what they consider major food allergens. And I wanted to show this for a few different reasons. So first of all, so if you are exporting your food product, that to be aware that not all are the same as you go to different countries. Also, so you can see the regulations may be grouped differently. So in the US, sesame isn't part of the major food allergens, but there are some other labeling requirements. In the EU, it's formally lumped together with food allergens. So again, just something to be aware of when you're looking at your product of what's in there, and especially if you are exporting. So now we know what is an allergen. Have some reasons of why we care about allergens in our food products. So how can we manage those food allergens? So allergen management is an overarching set of policies, procedures, and processes in the food business. And so they work all together to control the allergens at your facility. And so like HACCP, it requires senior management commitment, systematic planning, rigorous implementation. And so you'll need to have a written allergen management plan, and that's going to help show that you have due diligence, help your staff and your suppliers understand what exactly their role is in that management plan, and helps provide you just documented procedures to follow and help, again, your staff to know exactly what they need to do. And so part of that program, you should also have a recall plan. And so that overall plan you'll want that to sit within your broader HACCP plan, your different prerequisite programs that you need to have and operate with your good manufacturing practices. And so the very start of this plan, again, like a HACCP plan, should be done with a risk assessment. Specific. Every facility or retail shop is going to be different, and so it's going to have different hazards and need to be evaluated individually. Another big piece of that is knowing your raw products. So most allergens are brought into your facility through the purchase of raw ingredients. And so it's crucial to know the allergen status of the ingredients that you bring in. Certificate of analysis so that you can show that what is the allergen status and have that documented. Also, so what is the form that again, different products are brought in, powder, liquid, more whole grain pieces, all of that can make differences in your program. Ensure that you've considered any cross contacts and have detailed all the control measures that you have to reduce the potential for that cross contact within your facility, and ensuring that your staff also. For your SOPs, to make sure they are validated and that you are periodically checking those. And then rework. How do you handle rework? So again, part of your food, so making sure it's labeled, and that if it can be used in a into a different product, but not into a product that needs to be free from allergens. So another really important part, or a really recommended piece, is an approved supplier program if you don't already have one. So an approved supplier program goes a long way ensuring you have the full confidence in your ingredient suppliers. You need accurate information from them, and not just about all the other. You feel like the documents you're getting from them aren't complete. You'll also want contamination. Consider having maybe a So from the statistics, a short snippet. So looking at all those recalls, so the top recall reason, undeclared allergens. So where does all that come from? And so here's just a few errors that were in the top 3 that I found. Sure. And so it should be part of a process, not an end in itself. So using it properly, testing should be a tool to help you identify and quantify the presence of food allergens at particular points in your production process. It will also be able to use it to help verify and the effectiveness of your controls and your cleaning programs. So there are limits to what testing can do. So a single test can't guarantee the allergen-free status of a product. It may be a part of the process of doing a final check on a product, but it shouldn't be the only check that you have in your system. So for example, I'm going to go through a few points of where testing fits in. And so the first one would be the ingredient testing. So again, as we mentioned before, most allergens are brought in the production environment through your raw ingredients. So testing your raw ingredients is a really big piece of it, along with that approved supplier program. So if they have a certificate of analysis already showing the status that the product is free from the allergens. And so at the bottom of this slide here, there is a link. And so this is a really good resource. That's actually, again, from an Australian resource, the Allergen Bureau. And so it has a several page document going through where some unexpected allergens pop up, in particular in ingredients. So, and I have 2 examples there. So baking powder, does it include a carrier or a base, which can commonly be wheat flour. So while your ingredient statement may say baking powder, there's a definite risk of having a cross-contamination with a wheat flour there. So coconut milk or coconut milk powder, again, a common contamination there is from casein, which is a milk protein. So again, could be a source of an undeclared allergen that you might not be aware of when you're looking at your supplier. Oh, so one other item. So with ingredients testing, some raw ingredients can also cause interferences with the accuracy of the testing. And so in particular, those are products that contain polyphenols. And so examples of that, blueberries, onions, cabbage, blackberries. So if those are in your ingredient list that you may need to have tested, or in your final product, for also be sure to let your lab know so they can take action. Sorry, I guess I do have it here. So they have the ability to modify their extraction typically in most cases, but if they're not aware that that is in the product, then they won't know that. So it's really important to let your lab know if that is in your ingredients. So another step where testing can be really helpful is in cleaning validation. So often when doing cleaning validations or on-site verifications, you may use some quick tests, the kind of dipstick tests for a protein swab detection or ATP tests, which are really great tools for in the facility where you can get a really fast check of was the cleaning effective. The drawback of those tests is they are non-specific. So an ATP test is looking for organic material. It doesn't necessarily mean that it's an allergen. It could just be a protein of some sort. That's the same with the just non-specific protein swabs. It only tells you that there is a protein there or not there. It's not specific. And so the most effective way to validate your cleaning is through pre and post cleaning swabbing and then testing specifically for allergens. And so you want to do both pre and post because you want to see that the allergen was there in the first place with that pre-swab, and then the post-cleaning swab showing that you were able to remove it and ensure that that allergen was detectable in the first place. If you have potentially multiple allergens or difficult to detect allergens, you may want to consider using a carrier allergen. So for example, if you have a product that contains soy and wheat, the soy protein will typically be more difficult to detect than the wheat. So you may use that wheat allergen as a particular marker for watching is the cleaning verification or the cleaning effective. So some tips when you are doing swabbing is, so first of all, the swab supplies themselves are specific to the allergen assay. So you will not be able to use the same swabs that you would use for, say, your pathogen testing. They are different. So be sure to check with your lab to make sure that you have the correct supplies for that. These allergen swabs are typically dry, and then there'll be a separate tube or bottle of some sort with the swabbing solution, and those should be stored at room temp, not frozen. Also be sure that the operator that's going to be doing the swabbing has, clean hands, clean clothes, and wearing their gloves and changing those gloves as needed as they move through the facility. So the swab itself, you'll dip into the solution and you'll want to remove the excess liquid. The swabbing area is fairly small. So I have a couple examples there on the right of if you were to do just a small square, obviously the shape that you swab does not need to be a square, just as long as it stays under that 25 square centimeters total area. You'll want to swab it thoroughly in one direction and then swab that same surface in the opposite direction just to make sure you can get capture all and any allergen that is remaining on that surface. You want to dispatch that to the lab as quickly as possible, ideally within 24 hours for best results. The remaining protein that is in that solution that you've just swabbed potentially can degrade, which will reduce the chances of detection in the laboratory. If you cannot dispatch it immediately, you may want to check with your lab. In some cases, the sample may be frozen, but that's not appropriate for all allergens. For example, gluten can be affected by that. So be sure to check with your laboratory before you were to do that. And so when you get the results of those swabs, we also want to be sure that we're looking at those results with some caution. So determining allergen from a swab is generally not considered a truly quantitative result, and that's for a few different reasons. So the swabbing process can be highly variable. When you have different operators in different areas where you don't have an exact surface area, it can vary and then the amount of protein that you're capturing. So it's not always comparing apples to apples. The recovery can also vary. So if you're looking to capture multiple allergens in your, if you have multiple allergens in your product, the recovery can vary from one to the other. And that recovery can also be influenced by other contaminating items on the surface. For example, the the food itself, other food ingredients that are on that production line, or the cleaning chemicals themselves can also affect that recovery. So the final area for testing would be when we're looking at the end product itself. So one of the most difficult things about end product testing is that the different processes that your product has just gone through, especially if it's a highly processed item, it can alter the structure of those proteins, which is how we detect the allergens, is by those specific proteins. So in particular, increased temperatures and pHs can alter the structure. The end products also typically only have a small amount of allergen in them in the first place. The allergen potentially has been diluted with all the other ingredients, making them difficult to detect. And then again, finally, those cleaning agents or other ingredients within the product can affect the recovery. So although it is difficult, or more difficult in final product, the processing can increase the allergenicity of some proteins. So it's still an important part of your overall allergen program to still include that as part of the entire process. So whether you're sampling your raw ingredients or your final products, there's also some tips that we'd like to give you before you're sending sample to the lab. And so the primary concern here is that you are providing a representative sample to the laboratory to do that determination. And so it's really important to take those primary samples using a risk-based approach of how much you should sample and at what areas. And so you should be taking multiple units from various locations in the batch. And so the next question that we often get from customers is whether they should composite those samples. So if you've just taken 10 pallets of product and you are getting ready to ship them to the lab, are you going to send 10 individual samples, or are you going to send one composite sample where you've mixed all 10 samples of one particular ingredient? So we recommend compositing should be done only with caution. Testing the composite may dilute the allergen. So if you only had one positive pallet out of the 10, you've potentially diluted that allergen down that it may not be detected anymore. And so now you have product that, as it gets to the end stage, is maybe checked, found to contain allergen, and you've now lost 10 pallets worth of product, versus if you had checked them individually, you may have simply rejected one pallet of ingredient. So again, we just recommend that you look closely at the sampling before you decide to do a composite, and look at a risk-based approach for that. Once the sample is received at the laboratory, it's going to go through it's going to be homogenized. And so I have a little example here of what that looks like. Also help you understand of why compositing can be a bad idea. So if we have 10 potatoes, or as I mentioned, like 10 pallets, if you think of that, of 10 pallets of ingredients, the allergen, if it's a contaminant, will not be evenly distributed. So the red dots there, if we say that is our contaminating allergen in each of those potatoes. If you chose to composite those, you'd say, okay, I'm going to slice a little bit out of each one of these. So if the knife cuts the potatoes in half, and that was the little bit that you just grabbed from each of those potatoes. So now you cut that down, and you can see where in some cases you may miss allergen that you would have detected by taking these large pieces and leaving a large portion of the potato behind. So when we homogenize samples in the laboratory, it's very similar concept. So we will not want to cut away simply half and leave half. Instead, you would want to take it into very small pieces when we blend it, usually into the laboratory using specialized food blenders, so that we can get the most representative as possible and get that allergen, that those red dots we want to have as evenly distributed as possible, from which then we'll take our working sample in the laboratory to test. So this slide is showing just all the different areas where you may not think about where there are contamination possibilities. So even if you have a supplier verification program in place and you feel that that's a very strong program, that's not necessarily going to protect you from having allergen cross-contamination. And so there's still a lot of areas where it can come in. So that's where you want to ensure that you have a full allergen management plan that looks at all these different areas, and versus relying on a single COA from your supplier upfront and leaving that as your only check. So we want to make sure that we're reviewing the entire process when you're developing that program. So now I'd like to go through a little bit of the actual assay that we perform in the laboratory to detect the allergens. So we refer to it as ELISA, which stands for Enzyme-Linked Immunosorbent Assay. And so it's a technique that has highly specific antibodies that are going to bind to those epitopes on the allergen. And so again, just one more time with the definitions, because we're going to refer to them. So the allergen, that's the center picture there, that's the specific protein that we extract from the product itself, and the epitope, which is an even smaller portion of that protein to where the antibody is going to bind. So in the assay, it starts with a coated plate. These are usually, it is purchased as a kit. There's a number of different vendors out there that have, slightly different versions of it, but this is the basic concept. So we have a plate that has a capture antibody that is that's coated on it, and it's specific to a specific epitope of an allergen. So if we are looking for peanuts, it will only detect that specific epitope of that ARA protein in peanut. It will not detect milk, it will not detect egg, it will only detect that one. So we're going to take that extracted sample, it's placed into the well with the antibodies, and so you're going to have just a very small portion of what you've extracted will have the actual allergen. So it's incubated, and then that liquid is washed off, leaving only the allergen connected to the capture antibody. In the next step, we're going to add a detection antibody. So again, it has a portion that has a specific epitope to that allergen, which allows it to then sandwich the allergen in between. And so we actually refer to this type of ELISA as a sandwich ELISA. There are other types of ELISA techniques. This is one of the most common for allergen detection. So again, we're going to do a wash step that's going to remove all the excess that didn't stick to that allergen. And so again, you can see the little green dots there are allergens sandwiched in between our antibodies. We're then going to add an enzyme conjugate, and this again is specific to that previous enzyme. And so when we wash it away, only the ones that are bound are going to stay connected to the plate. The excess will wash off. So if you had a sample with no allergen, every time you're doing that wash step, all the excess reagent would simply be washed off. And then our final step here, we're going to be adding a substrate. And so this is a reagent that is going to allow us to actually detect it with a color change. And so that's incubated, and that enzyme conjugate, the enzyme is what acts on that substrate in order for it to change color. So here's just a picture of a plate that had been ran. So the enzyme has changed color there. And so the amount of color detected is directly correlated to the amount of allergen present. And so calibration standards are ran at the same time with known amount of allergen, and we can compare that and create a calibration curve so that we can quantitate exactly how much is there. And again, if there was no allergen at that very first step, we'd never get our allergen or antibody sandwich, and so there would simply be no color change there. So the ELISA technique, it's very common for allergen analysis because it has a number of advantages. So ELISA is particularly suited for detecting proteins, and in the case of allergens, it is proteins that are the most common cause of allergies. So it's a very good fit in terms of the target that we're looking for. It's also fast and relatively easy to perform, potentially not easy enough to do in the plant, but a fairly quick in the laboratory. And most laboratories have equipment, say, capable of doing it. So it's not a rare thing to find in a laboratory. It's also highly specific. The antibodies that are used.
Questions using the Q&A function in your toolbar at the bottom of this webinar. I will give everyone a few minutes to type in your questions. And in the meantime, I'm going to review a brief notes. This webinar presentation has been recorded. All participants of this webinar will receive a follow-up email once the recording is available to view. We also post our webinars on our ALS Global website and our ALS YouTube.
Okay, so so in terms of sending out your sample, so I went through a few of the tips in terms of collecting a sample. So that's really important, getting a representative sample, obviously, whether you're doing it internally or externally to send, testing it yourself or to an outside lab is incredibly important, of getting it representative first. And then when sending it to the outside laboratory, sending it as quickly as possible, especially if you're looking at a swab, because the
sensitization, example,
and a lot of the regulatory requirements around them are
in the product. How does a company typically react if small amounts of
so how you react in a situation, and so if you have a test and release program where the product was held, then that obviously, and that is your trigger for whether you release the product or not. That may mean the product gets moved to a different purpose, like it may be reworked into something else. It also would depend on the level that the allergen was found. So for a number of items, say, for example, gluten, if you are labeling your product as gluten-free, there is a set limit that you must meet. If you're below that limit, it's okay that it was detected. You'll still be able to label it as gluten-free as long as it meets the less than 20 ppm. So there's a few different details there that could make a difference of how your company might need to have to react to that situation.
Okay, I think that's those are all the questions.
Okay, well, thank you for all the questions. If anyone does have any additional questions that they think of later, or you're struggling with your allergen management program, we have experts here that can help maybe get you through some of those steps or help give you some recommendations. So feel free to reach out through email or phone.
Thank you, Angela, and thank you everyone for attending this webinar. Enjoy the rest of your week.